Here we go with problem number 22. We're given some information at the top of the page, and we're going to use this information to answer questions. So you can see that in number 22, we're integrating from negative 2 to 5, f of x plus g of x. So we need to find the integral of f from negative 2 to 5, and we need to find the integral of g from negative 2 to 5. And you see that we are integrating the sum of two functions. And the integral of a sum is equal to the sum of the integrals. So the integral of f is 18, the integral of g is 5, so the integral of f plus g from negative 2 to 5 is 23. Too easy. So let's take a look now at number 23. They are asking us to integrate f plus g minus h. All right, let's go to work. F is 18. The integral of f is 18. The integral of g is 5. And then we're going to subtract the integral of h. The integral of h is negative 11. Minus negative becomes plus. So we get 34 as our integral value. Okay, too easy. Let's go on to number 24. See this constant multiple of 4? We can think of this as 4 times the integral from 5 to negative 2 of g of x with respect to x. So first of all, we need to be careful here. Did you notice that the limits of integration were reversed? So the integral of g from negative 2 to 5 is 5. So the integral of g from 5 to negative 2 is going to be negative 5. Switching the limits of integration gives us the opposite answer. So instead of 4 times this integral, we get 4 times negative 5, which is negative 20. That's our story, and we are sticking to it. Let's move on to number 25. Number 25 provides a little bit of a challenge for us. Challenge now because it's new to us. We're integrating g of x plus 2, and we don't see the integral of 2 anywhere in the list. Here's what we're going to have to do. We're going to have to integrate in our minds g of x from negative 2 to 5, and then we'll have to integrate 2 from negative 2 to 5 and add them together. Well, the integral of g from negative 2 to 5 has been done for us. That integral is 5. Now integrating 2 is going to take just a little bit of thought. If you think of y equals 2 as a function, and you graph this function, here's y equals 2. So if we integrate from negative 2 to 5 and think about what this represents, you can see that this gives us a rectangle with an area that we can compute. So let's figure out the base. The base goes from x is negative 2 to x is 5. So the base is 7. The height is 2. 7 times 2 is 14. The area of the rectangle is 14. Oops. This is getting crowded. Let's move it over. So now, 5 plus 14 is 19. And we solved the tricky problem. It is 5. Number 26 is going to be very similar. Let's get rid of this scratch work. Okay. Number 26, we're integrating f minus 6. We're going to think of this as the integral of f, and then either minus the integral of 6, or you can think of this as plus the integral of negative 6, however you think about it. Let's go to work. The integral of f from negative 2 to 5 is provided, no big deal. Now we're going to subtract the integral of 6 from negative 2 to 5. So let's think of a graph. If you graph y equals 6, we're going to get a horizontal line. We're integrating from x is negative 2 to x is 5. So the region bound by this curve in the x-axis is a rectangle once again. The base of the rectangle is 7. The height of the rectangle is 6. 7 times 6 is 42. And 18 minus 42, and that's negative 24. That's all we had to do. No big deal. Moving on to number 27. Okay, in problem number 27, we have a little bit of a problem because the limits of integration of our function go from 0 to 7. And in the problem statement, we don't have limits of integration from 0 to 7. The integrand is h of x minus 2, and in the problem statement, the integrand is h of x. So a little discrepancy. So let's think about what's going on here. What does the x minus 2 in the input of h do to the graph of h of x? Well, the x minus 2 shifts us 2 places to the right. And if you think about it, now we have the limit of integration in the original statement is negative 2, and if you shift 2 to the right, we get 0. The upper limit of integration in the original problem was 5. If we shift 2 to the right, we get 7. So let me try to illustrate what's going on here. Let's take a look at the graph of some arbitrary function h. And let's look at the integral of the h from negative 2 to 5 graphically, which is to say, let's look at the area between the curve h and the x-axis. Well, let's just imagine for a minute if we took this exact same region and shifted everything 2 places to the right. You see that the area of the region from 0 to 7 is exactly the same as the area of the region from negative 2 to 5 because the whole function shifted over, not just the x values of the area, but the whole function shifted over. Therefore, for number 27, we're going to get negative 11, the same value that you would have if we left the function h of x alone in the beginning. Let's look at the last few problems now. Well, just to save time, number 28 is the same type of problem as 27, a little bit different. But let's look at problem number 29. This is the new type of problem. This is the first kind of trick that we've really got. And we'll let you try number 30. So number 29, take a look at the limit of integration. Now, f of x was shown above 2 times. An integral from negative 2 to 5 and an integral from negative 2 to 8. So let's think of it like this. The integral from negative 2 to 5 of f of x plus the integral from 5 to 8 of f of x is going to equal the integral from negative 2 to 8 of f of x. Now we have values for 2 of these integrals, and we need to solve for the third. You can see here, when we integrate f from negative 2 to 5, we get 18. We don't know what the integral from 5 to 8 is. That's the unknown. Let's call it capital I for integral. And then the integral from negative 2 to 8 was given over here, which is 0. So with algebra, if we want to solve for big I, just subtract 18 from both sides, we get 0 minus 18 or negative 18. This is how we would do a problem like number 29. We've thrown a lot at you today. The good news is you have 4 days to practice this and process through it before our next class. Our next class is Tuesday. I want to remind you that we have a quiz Tuesday that will cover U substitution and Riemann sums. Review that stuff. If you have questions, do your best to work through it with solution guides and videos online. If you need help, I'll be available Monday during seminar and Monday after school in the library for tutoring. So feel free to stop by if you have questions before we take our quiz Tuesday. Thank you, and have a nice weekend.